Okay, my name is Philip Melo, and today we are going to talk about what does it mean PM GenAI and how we can boost the quality of machine learning that is downgraded by the data quality. So that is a fundamental problem in public health informatics, in healthcare informatics, but in any discipline, because raw data usually have lots of deficiencies. We know how to work with them, but still, we cannot approach a high accuracy. And this is kind of a pivotal problem. And many organizations, they are just a little bit disappointed with the efficiency of the artificial intelligence, machine learning algorithm, because they say that they do not produce required quality. So today we'll try to correct this, and we will show a powerful method that actually can beat this attitude to machine learning artificial intelligence. And I hope that this method will be accepted by many researchers, health care providers, informatic technologies, and so forth. So let's start it. Okay, so high quality data is accurate, completely reliable, relevant, and timely. It helps people make better decisions, run systems smoothly, and get meaningful insights. So everybody talks about high quality data, but in almost 90% of data we see in different areas, not necessarily in healthcare and public health, but in other engineering, science, biology, everywhere. The raw data is quite low quality or middle quality. It's very rare when we have high quality data. And so we need to do some work. So poor data quality can lead to bad decisions, financial losses, or inefficiencies. And of course, when you apply this to public health care, for the poor data quality gives us inaccurate result, and this is can be detrimental, can be cause problems. That's why organizations often invest in data quality tools and processes to keep their data clean and usable. That is quite important. Okay, so conventional pre-processing includes 5 steps, and the first one is data profiling. And I had already a lecture. It's on internet. You can see about data quality. There is quite in all detail that is explained the pre-processing steps. Okay, so the data profiling includes scans of the data sets to understand anomalies, patterns, quality issues before ingestions or use. Okay, there is some very good tools for that, like Talent, Informatica, OpenRefine, Pandas profiling. And I suggest to my students to use Python, because Python has a very rich library of different things, and it is optimized. And it's not only just a language, but it is optimizer, okay, which is very important. Okay, so then we have data cleansing or data wrangling. So what the data cleansing does, it removes or fix inaccuracies, outliers. Outliers, very important to remove because they can really damage the decision-making systems and lead us to inaccurate results, duplicates, and so forth. So then it includes also standardization. We spoke about this in previous lectures, deduplication, correcting invalid entries, and so forth. Yeah. However, the problem is that although we use traditional approach to data quality improvement, the accuracy may be poor. So suppose you clean the data, you have the data nice and clean and so forth, but still you have the data, the results of application of your data sets to, let's say, real situation, realistic things when we need to have accurate results, we fail, and why it is. So it is great frustration. You see that I did all this kind of data cleaning and outliers removed. I did feature engineering. I did lots of things, but still I cannot get good results. And this is cause frustration. Today we are going to talk about a new algorithm that solves many problems in data quality and gives us very, very good accuracy results. Okay, so what does it mean, Pandas data frame? As I said, that I teach my students to use the different platforms, like for instance, we use Tableau, and we use other things, but Pandas is good because it has very rich libraries, and also it is optimizer. So when you use a data frame, it gives us, for example, this is NAN. Here, for example, was blank, okay, of data. So and outliers you can see, let's say in the box plot. This is we have IQR, and this is Whiskys. So the left side, the right side of that, and this is left side. So that everything that goes beyond Whiskys, we can call as an outlier and check it once more. So outliers should be removed, and we have powerful method to remove outliers. Okay, then another thing is feature engineering. And feature engineering, we use, let's say, build a heat map, or we use other technology to see the correlation between the features and outcomes. And outcomes is our target. For example, a person is sick, or it is detail is has deficiencies and so forth. But also we have features, and the features can be different. It can be many features, and so therefore heat map is a very good tool to understand the correlation and see if, for instance, the features very much correlate. Means that it's redundancy. We can also consider them as duplicates and remove. Okay, so in feature engineering, for example, in the data set that I show you, that the features that play a pivotal or a very important role, there are only 4 out of 8. Okay, so what happens is that then when we use our different algorithm, for example, logistic regression, decision tree classifier, AdaBoost classifier, a support vector machine, random forest classifier, gradient boosting classifier, KNN, and so forth, it doesn't matter what kind of data it is. And we cannot get accuracy more than, let's say here, 75, 78%. And of course, what does it mean 78%? 78% or 75%? It means that out of 100 patients, you wrongly classify or provide diagnosis to healthcare provider, 25 patients. So this is not possible. This is not acceptable. And we need to, in data science, it is very crucial to move it up, to increase the accuracy. And now I will show you how we can do it. And I strongly recommend you to try to use this algorithm in your work, and you will see what is the actually power of this. You can get very high accuracy. Okay, in that. So this is when we apply after cleaning the data, after feature engineering, after removal outliers and so forth, we cannot go beyond 75. And this data set was considered by various researchers, and they found the same thing, that they cannot come closer to 80%. So it is less than 80%. Even the powerful algorithm like support vector machines that we are using in data science very often fails to go above 80, let's say 82. Okay, so what to do? What to do? So that is, there is no sense to develop new algorithms, machine learning, artificial intelligence, if we do not know how to work with data quality. That's what one of the objectives of today's lecture. So it doesn't matter what instrument you use. If the data quality is not good, you can never get good results. Now, what happens is that can AI help resolve this problem? So this is PM GenAI. I represented in my paper in 2024, and now I will just give you some examples of that we can discuss it, how it works. Okay, and that our goal is to improve accuracy. So step one, you see, what happens is that when we have data, let's say a patient is sick or patient is healthy, we have two clusters. 0, let's say we put for no disease, and 1, he has some disease, for example, diabetes, cardiovascular disease, so forth. We call this binary classification in data science. So what happened is that we have two clusters, and these two clusters are absolutely deterministic. So we have various features, and we have observation that come from these features that it was established that the person is sick or person is healthy. Okay, so it is very deterministic. So what we do now, we're not going to go through the deterministic route. We'll take the route of probability, of stochastic rule, and we can see what's going on and what kind of give us more information and more and the instrument to work to leverage various technique applied to stochastic things. So now, for instance, we have original data. The augmented data is this one. So how to augment the data? There is many procedures. For example, you can use Bayesian network. You can do this and that. But now you add this data, this probabilistic data, to original data, and you have this one. And now each point has some probability that belongs to cluster 0 or cluster 1, but has now probability. Okay, so what happens is this is we for instance add more data, augmented data compared to this one. Now what happens is now let's run conventional machine learning. It doesn't matter because the accuracy almost the same. Okay, we can run a deep learning algorithm, or you can run logistic regression. You have this confusion matrix, which gives you that, let's say, from you have 42 patients, let's say, who are identified that they do not have disease, but you wrongly identify 6 patients who are absolutely healthy. You identify them as sick. Okay, and here we have out of 37 who are really sick, okay, you identify this as an absolutely healthy person. Okay, so this is wrong diagnostics that what machine learning gives. So we got this the best result, but other machine learning techniques gives much worse results. Okay, 60%, 70%, even 50%. Okay, so the conventional machine learning gives, in this case, 82%. We took the best, as I said, 82% of probability, or 81% of accuracy, 81% of accuracy. Okay, precision and recall the sensitivity. You have 0.83 and 0.81. So we have 81%, which is quite rare. Usually it is below 80. Now, what we do here, we did just augmented. We just put stochastic data included in there. And since we have now data sets much bigger, we know from machine learning that machine learning likes to work with larger data sets. And we have now this one. And we were not so surprised that when you just augmented data set, you have a little bit better. Instead of 81, you have now 86%. Okay, accuracy. But this is still not acceptable because you also, in this case, for example, in 80 patients, 12 patients were diagnosed wrongly, so this is no good. So what we do now, since I told you that now we have each point has now probability, we can drop if probability is below your threshold, okay? So what does it mean? If probability of this patient, of data of this patient, subject, it is conditional probability, subject that belongs to specific cluster, it has to be greater than some threshold that you put accuracy that you want, okay, you desired accuracy. And then this artificial intelligence algorithm, PM GenAI, will take care of everything, okay? So it will analyze the data, it will look at the patterns, and it will drop the data, which probabilities lower than this threshold. Okay, and those results are amazing. Out of 19%, only one, 90 patients, only one was diagnostic poorly. But you can also elevate the threshold, and you can get numbers close to 100%, can be 98, 99. So in this case, only 1%. So it is tremendous improvement in accuracy. And since it is not only limited by deep learning, it can be used to any machine learning techniques. And when we use this to all these methods that I showed you before here, okay, then you come to almost 95, 98, 99% of accuracy. So this is tremendous improvement. Okay, so that is how it works. And in our case, we have 97% improvement, 97% accuracy, which is quite high. And I do not know any other machine learning technique that gives this kind of accuracy, or even can give more, even 98, 99, independent threshold. So we just jumped from 81 to 96, actually to 97, but it doesn't matter. And this is, of course, is a very encouraging step ahead in data science. Okay, so thank you.